This is Rob Schaper from the Johnson Controls Facility Performance Indexing team speaking. This video will highlight the features and functionality of the Facility Performance Indexing for Lifetime Commissioning Software, also known as Full FPi. Full FPi uses the powerful indexing analytics engine to simplify fault detection and diagnostics into useful and actionable data. This data empowers building owners, operators, and maintainers to ensure the building automation system is working as it should throughout the lifetime of connected equipment. Let's begin by looking at FPi's fault detection and diagnostics, looking under the Indexing Reports tab. For a summary of the FPi indexing analytics, we're going to run the performance report. The system performance pie chart summarizes the performance of major pieces of equipment, such as boilers, chillers, air handlers, VAV boxes. 3 colors are used to indicate the severity of faults detected by the FPi analytics. Green represents that there are no faults and that it is performing as it should. Yellow is used to indicate minor faults, and red is used to indicate major faults. To identify systems with major faults, simply click on the red slice of pie. The value column represents the indexing analytics number, a value that could be as high as 100 if everything is working perfectly, or as low as 0 if there are major faults detected. Double-clicking one of these systems creates a chart of the indexing analytics for the individual components of that system. All charts with a red, yellow, and green background show indexing analytics values. To quickly identify the components, either hover over one of the lines or hover over the legend. Click the Components tab to show the latest indexing analytics values. Double-clicking on the lowest value component will load actual values from the building automation system. Returning to the performance reports, let's look at the components pie chart. Components are individually indexed and analyzed control sequences of a system. One such example is zone temperature compared to zone temperature setpoint. This report can be sorted to quantify how many faults have been identified by the type of the component. Double-clicking on the component type shows the list of identified faults. Double-clicking on one of the faults shows a chart that contains the actual data from the building automation system, revealing poor control. Clicking on the grid button displays the data in a table, readily exportable in an Excel file format right to your desktop. The Input tab shows the last values read for the inputs. The Configuration tab displays the basis for the indexing analytics, which for temperature is typically plus or minus 3 degrees versus its set point. The Data tab returns you to the chart where today's data is available, along with up to 120 days of historical data. This trended data is completely independent of any trends which may or may not have been set up in the building automation system and is available for all indexed data. Another indexing report is the Compliance Report, which lists the worst 25 performing systems right now, along with the detected faults in the diagnosis column. As with other systems, double-clicking on the system will reveal the indexing analytics charts. Clicking on the Components tab clearly shows the identified faults, and clicking on the component loads a chart with actual data to aid with further troubleshooting. The Compliance Report can be delivered daily via email and can be used as a catalyst for a proactive versus reactive maintenance strategy. The next indexing report is the Root Cause Report. This report links major equipment together, along with the systems that are fed by that equipment. The Affected Systems tab shows the impact that the major equipment with active faults has on the children's systems. The Performance tab lists the faults of the parent. Focusing on fixing the parent system's faults will likely correct the faults in the affected children. The next actionable report is the Indexing Fault Report, which provides insight into the systems with the most faults over time. This report has user-selectable filters built in to help you focus on critical systems like central plant and air handling equipment. Addressing critical system faults first is likely to resolve many downstream issues at terminal units. The air handling unit with the most faults detected, 2,490, is based on the number of faults logged over the past 30 days. The recent data chart summarizes how many data samples per day contain faults out of the 96 analyzed data samples for that day. Clicking on the system will enable you to identify the faults and take action to fix them. You also have the ability to look back at weekly summarized faults, covering 52 weeks, and monthly summarized faults, covering 24 months. The final indexing report is the Performance Snapshot Report, which provides the user with a progress report based on FPi detected faults. This chart shows the percentage of equipment over the last year with active faults at 4 p.m. represented in red. Another option is to display Monday through Friday faults only. As systems with faults are fixed and/or maintained, the percentage of faults per day can be expected to decrease over time. The Display Week-on-Week option quantifies equipment with faults over specific intervals. The fault reduction value shows an increase or decrease in faults compared to the previous column. These performance snapshot reports reveal the successes and/or failures of current and past strategies for lifetime commissioning, maintenance, and repair. Next, let's explore the Reporting tab, which has two sections, Standard and Extended Reports. Extended Reports contains reports previously set up that contain totalized data, such as runtime and meter totalizations. Standard Reports contains a metrics report, which includes version and licensing data. An audit report tracks FPi usage by user. The diagnostics report identifies communication errors and offline points. And finally, we have the FPi rules. FPi rules enable the user to do a further analysis of collected data. There are three types. Let's look at a system snapshot first. A system snapshot analyzes current data. This previously created rule is looking for zone temps less than 66 degrees or greater than 76 degrees right now. A value report analyzes historical data. This example is looking for zone temperatures below 64 degrees between the hours of 1 a.m. and 6 a.m. today. No results from today's data. A rule analysis can be made, allowing you to select a different time range for the rule. Using this week, the rule returned 1,203 zone temperature readings that were below 64 degrees between the hours of 1 a.m. and 6 a.m. And last, the aggregated daily report totalizes data and can be configured to show minimum, maximum, and even average values over a period of time. This example is looking for supply fans running more than 8 hours today. A rule analysis from yesterday lists the supply fans that were on for more than 8 hours and their total runtimes. Let's see how an FPi rule is created. FPi rules are designed to be easy to use and produce actionable results. Here is an example creating an FPi system snapshot rule that will find zone damper actuators that are slipping or are stuck closed, most likely caused by a loose set screw. Clicking on the white box presents you with all the points associated with terminal equipment. This rule will analyze both the zone damper's position, being over 95% open, and the supply airflow being less than 50 CFM at the same time. Enter a rule name, save, then apply the rule. Since other data points from the equipment may be needed for further analysis, all the points are presented to you initially. The Format button allows you to select the relevant points you need. Saving and applying the format changes will retain those changes for all subsequent times the rule is ran. Thank you for taking time to learn about FPi. Need more information about FPi? Have questions? Get answers today by contacting members of the FPi team or by visiting the FPi website.